Number 19 is graphing a piecewise function. So for the domain where x is less than 0, we're going to graph the absolute value function that's been shifted down 4. Remember, the absolute value function looks like this, so everything gets shifted down 4. My vertex is normally at what point? 0, so that point at 0 gets shifted down 4. Do I put an open circle or a closed circle on that vertex? Open, because x is strictly less than 0. So for x is less than 0, I'm going to graph this absolute value function, which looks like this. And then I have a constant function when x is greater than or equal to 0 at -4. So here, for this function, do I put an open circle or a closed circle at 0, -4? Closed. So I put a closed circle here, and then this is a constant function, which is just a horizontal line. Is this function continuous or discontinuous? It's a continuous function. I didn't ask you that on this problem, but that is something that I would expect you to know on your test. So I'm taking advantage of a teachable moment here. If you can draw the picture without picking up your pencil, it's continuous. Let's say this would have been 4 instead of -4, then I would have had a graph that came up here and been a horizontal line. That would have been discontinuous. So if this picture would have looked like this, that would have been an example of a discontinuous function. If there would have been an open circle here, let's say that it would have been undefined at x equals 0, that would have been discontinuous as well if there's a hole in the graph. This just would have been a removable discontinuity, but it's not. It's all continuous because x is equal to 0, -4. On number 20, we're asked to divide and write our answer with positive exponents. We're dividing a polynomial by a monomial. Whenever you do that, all you do is distribute that denominator and divide it across each term. So I could rewrite this as 49x to the 8th divided by 7x to the 5th minus 49x to the 7th divided by 7x to the 5th minus 21x to the 5th divided by 7x to the 5th plus 14x cubed divided by 7x to the 5th plus 14 plus 3x squared divided by 7x to the 5th. Now we just cancel where we can. X to the 5th goes into x to the 8th and leaves behind an x cubed. 7 goes into 49 7 times, so I end up with 7x cubed for my first term. X to the 5th goes into x to the 7th, leaving us what on top? X to the 2nd, because remember, when we divide with a common base, we subtract the exponent. 7 minus 5 is 2, and 7 goes into 49 7 times, so this will be minus 7x squared. Minus, and then 7 goes into 21 3 times, and our x to the 5ths cancel out. Plus 7 goes into 14 7 times, and now when I divide these 3 x's on top into 3 of these x's on bottom, that leaves behind an x squared in the denominator, so this will be 7 over x squared. Thank you. 7 goes into 14 2 times, so this would be 2 over x squared. 7 won't go into 3, but x squared will cancel with 2 of the x's in the denominator, leaving me an x cubed, so this last term would be 3 over 7x cubed, and that would be our final answer. When you divide by a monomial, a single term, distribute your denominator and then simplify each term one at a time. That's the easy way to do it. On 21, we're asked to divide the first polynomial by the second and then state the quotient and the remainder. We're going to do this one using long division, and then if you want, we'll use synthetic division on the others. So when I use long division, I take that x plus 5 and I put it on the outside, and I have 2x cubed plus 6x squared minus 26x minus 30. When I do long division, I just look at the first term here divided by the first term here. So that would be 2x cubed divided by x, and when I divide 2x cubed by x, I get 2x squared. Now I need to distribute. 2x squared times x is 2x cubed, and 2x squared times 5 is 10x squared. Now we need to subtract these terms, and these first terms are going to cancel out, and 6x squared minus 10x squared is negative 4x squared, and then bring down the minus 26x. So when I divide negative 4x squared by x, I get negative 4x. then I multiply and distribute. So negative 4x times x is negative 4x squared. Negative 4x times 5 is minus 20x. Then I need to subtract. Well, subtracting is just changing your signs and adding. The first terms are going to cancel out, and negative 26x plus 20x is negative 6x, and then bring down the negative 30. Then I once again divide the negative 6x by x and I get negative 6, and then I distribute. Negative 6 times x is negative 6x, and negative 6 times 5 is negative 30. And then I need to subtract, so I change my signs and add, and my remainder here is 0. So what does that mean about this x plus 5? It's actually a factor of this polynomial, and my quotient will be the 2x squared minus 4x minus 6. Now, do y'all want to do synthetic division on this one? When we set up the problem with synthetic division, I need to put my root right here. If x minus 1 is what I'm dividing by, what number goes here? A positive 1. And then I write down my coefficients in front of the variables here. And if I have a missing power, and I do, I have a couple of them, I replace that with 0. So I have 1x to the 5th, 4x to the 4th, no x's to the 3rd, no x's squared, a minus 3x, and a minus 1. Does it make sense where these zeros came from? Therefore, the missing powers of x up here, I have a x to the 5th, x to the 4th. This would be the x cubed, x squared. There's my x and my constant. So with synthetic division, you begin by dropping down that first term, and then you just multiply going this direction. 1 times 1 is 1, and then we add going this direction. 4 plus 1 is 5. And then we do 1 times 5 is 5. 0 plus 5 is 5. 1 times 5 is 5. 0 plus 5 is 5. 1 times 5 is 5, and so that goes up here, and negative 3 plus 5 is 2, 1 times 2 is 2, and negative 1 plus 2 is 1. This number right here represents the remainder. In synthetic division, the last number is always the remainder, so my quotient will be 1x raised to what power? It's going to be 1 less than what your original. So it's going to be x to the 4th plus 5x to the 3rd plus 5x squared plus 5x plus 2. And my remainder here is 1. So if I were to write this out as a polynomial, what I would write is x to the 4th plus 5x cubed plus 5x squared plus 5x plus 2 plus 1 over x minus 1. On 23, we're told to use synthetic division to divide the first polynomial by the second polynomial. So this is the factor. What number would I put right here? A negative 2 or a 2? I'd put a 2. What will my constants be going across the top? I know I've got 1x to the 4th, and then a 0 for the x cubed, a 0 for the x squared, a 0 for the x, and then a constant of 16. So we begin by bringing down our first term, and 2 times 1 is 2, 0 plus 2 is 2, 2 times 2 is 4, 0 plus 4 is 4, 2 times 4 is 8, 0 plus 8 is 8, and 2 times 8 is 16, and 16 plus 16 is 32. So my remainder is 32, and I would say x to the 4th plus 16 divided by x minus 2 is equal to x to the 3rd plus 2x squared plus 4x plus 8, and then I would say plus 32 over x minus 2. In order to use synthetic division, you have to have a linear factor where the leading coefficient is 1. On 24, we're told to use the remainder theorem to find the remainder when f of x is divided by the given factor. Do you remember how the remainder theorem works? It says the remainder when I divide this polynomial by x plus 2 is going to be equivalent to f of negative 2. You take the root and plug it into the function, and whatever you get is the remainder. So this will be 3 times negative 2 cubed plus 3 times negative 2 squared minus 7 times negative 2 plus 3. Negative 2 cubed is negative 8. Negative 2 squared is 4. Negative 7 times negative 2 is 14, and plus 3. So that gives us negative 24 plus 12 plus 14 plus 3. So that's going to be a negative 12. So that'd be a positive 2 plus 3 is 5. The remainder when I divide this function by x plus 2 will be 5. On 25, we're told that the graph of either a cubic or a quartic polynomial with leading coefficient of either positive 1 or negative 1 and integer zeros is shown. Write the complete factored form of this function. So the complete factored form is going to be f of x equals, first of all, is this a cubic or a quartic? Third degree or fourth degree? My endpoints are going in opposite directions, so will my degree be even or odd? Odd, so that means that this is the third degree. I have two zeros here. Is my leading coefficient going to be positive or negative? Negative, because it's going down, it's decreasing. Remember, negative starts at the top and works their way to the bottom. So this will be negative. One of my zeros is at negative 3, so a factor would be x plus 3. What will be the multiplicity of this factor? 1 or 2? When it touches the x-axis but doesn't cross, what's the multiplicity? 2. Odd multiplicity crosses the x-axis, even multiplicity touches the x-axis. Because my graph just touches here, this is going to be an even power on that root or on that factor. My other factor is at x equals 2, so that factor will be x minus 2. Now I have a third degree polynomial because I have an x squared times an x, and that gives me an x cubed, so I know I've got this right. And we've kind of talked through all of the things that we looked at. We looked at the endpoints going in opposite direction to tell us that we had an odd power. Because it started at the top and worked its way down, we knew the leading coefficient was going to be negative. We take our x-intercepts and write those as factors. Anytime your x-intercept or your graph touches at that x-intercept, you need to have a square on your power. And if it crosses, then you need to have a first degree. If it crosses and kind of flattens out there, you'd have a third degree. On 26, would this be a third degree or a fourth degree polynomial? Because the instructions are the same for 26 as they were for 25. Fourth degree, and is my leading coefficient going to be a positive or a negative? Positive, because my endpoints are going up. So then I look at my x-intercepts and I write those as factors. So I'm going to have a total of 3 factors here because I have a total of 3 x-intercepts. My first factor here is going to be x plus 3. The next one's going to be x minus 1 from this one, and then x minus 3. But that's only 3 x's multiplied together. That's an x cubed. You told me this is an x fourth. It has to be a fourth degree. What do I do to make it an x to the fourth? This factor needs to be squared because the graph just touches at that point. It doesn't cross. So there's my 4 x's. 1, 2, 3, 4. You know a lot of stuff. The hard part's going to be remembering it at the time that you need it. On 27, we're asked to write the complete factored form of the polynomial given the indicated 0. So here we're given a 0. That 0 means that what will be a factor? It means that x plus 1 is a factor if this is a 0. So then I could take this cubic function, divide it by x plus 1, and that'll work that cubic function down to a quadratic function that hopefully I can figure out how to factor. So if I'm going to use synthetic division to divide this. If I've got the negative 1 goes here, what constants go across the top for synthetic division? So I bring my first term down. Negative 1 times 1 is negative 1. 9 minus 1 is 8. 8 times negative 1 is negative 8. 24 minus 8 is 16, and negative 1 times 16 is negative 16. That means that my remainder is 0. And my other factor here is x squared plus 8x plus 16. This will factor into x plus 4 times x plus 4. So I've got a total of 1, 2, 3 factors, which means that I can write my function as x plus 1 times x plus 4 squared because this factor is repeated. And that would be the completely factored form for this polynomial. On 28, we're asked to write a polynomial in complete factored form that satisfies these conditions. Let the leading coefficient be 1. So we're told what the leading coefficient is. The degree is 7. That means I need a total of 7 factors. My zeros are 8 with a multiplicity of 3 and -7 with a multiplicity of 4. So my function is going to be, if 8 is a 0, what would the factor be? X minus 8. The multiplicity of 3 means that that factor is cubed. -7 is a 0. That means that I have x plus 7 as a factor, and the multiplicity on that factor is 4. So I've got x cubed times x to the 4th, and that's x to the 7th. So I do have a 7th degree polynomial. This one was pretty easy. I think reading it and understanding what it was asking for was probably the most difficult part of this problem. But if you're given a 0, you change the sign to write it as a factor. The multiplicity is just the power on that factor. That's what multiplicity means. On number 29, we're told to find the x and y intercepts, determine the multiplicity of each 0 of f, and then graph the function. So for part 1, we need to find our x and y intercepts. Which do you want to find first, the x-intercepts or the y-intercepts? How do you find x-intercepts? So to find our x-intercepts, I set f of x or y equal to 0 and solve for x. So that gives me 3 times x plus 2 times x plus 1 squared equals 0. Well, this is going to be equal to 0 if x plus 2 is equal to 0 and if x plus 1 is equal to 0. 3 is not equal to 0, so I just set my factors equal to 0 and solve for x. And that means that I have an x-intercept at x equals -2 and at x equals -1. Since I have to sketch this graph, I'm going to go ahead and plot those points at -2 and -1. Then I want to find my y-intercepts. So to find my y-intercepts, I'm going to set x equal to 0 and solve for y. Remember, y is equal to f of x, so I get f of 0 is equal to 3 times 0 plus 2 times 0 plus 1 squared. So that's going to be 1 squared is 1. 1 times anything is that anything, so then that's going to be 0 plus 2 is 2, and 2 times 3 is 6. So I have a y-intercept at 6, and that's going to be this point right here. Part 2 says to determine the multiplicity of each of the zeros. So the multiplicity of our 0 at -2 is what? 1, because that's raised to the first power, and the multiplicity of our 0 at -1 is 2 because it's being squared. Why is that significant? Because here at -2 the graph is going to cross the x-axis, but at -1 it's going to touch the x-axis. Now this is a cubic function, so our endpoints are going in opposite directions, which means that, and it's got a positive leading coefficient, so we start out going up, we cross the graph here, touch here, and then go back through our y-axis right there. And that's how you would draw the graph based on the information you got in 1 and 2. So these first 2 steps give you enough information so that you can sketch the graph. On 30 and 31, we're asked to solve the polynomial equation symbolically. That means that I need to factor this and then set each factor equal to 0. Do I have a common factor I can pull out of this? X is your common factor. You always want to pull out a common factor if you can, because that's the easiest way to work this down to get it completely factored. So if I factor an x out of this first term, I'm left with the x squared. Out of the next term, I'm left with the 5x, and out of that last term, I'm left with the 6. Will this factor further? Yes, or I wouldn't have done that, right? So this will be x plus 2 and x plus 3, because 2 times 3 is 6, but 2 plus 3 is 5. My solution here is going to be x equals 0, x equals -2, and x equals 3. And I get those answers by setting each one of these 3 factors equal to 0 and solving for x. On 31, do I have a common factor I can pull out? X. And when I do that, I'm left with x squared minus 16. Will this factor further? This is the difference of 2 squares, isn't it? So that would be x plus 4 times x minus 4. And then I just set each factor equal to 0 and solve for x. And what do I get for my answers here? 0, -4, and 4. On 32, We're told that the graph and equation of the polynomial are given. Determine the number of real zeros and the number of imaginary zeros. So this is a fourth degree polynomial. The total number of zeros has to be equal to 4. Your real zeros happen where your graph crosses the x-axis. So that means that I have 2 real zeros right here. And then if I have 2 real zeros and I need 4 zeros, how many complex zeros do I have? So I have 2 real zeros and 2 complex zeros. On 33, we're asked to find the complete factored form of the polynomial that satisfies the given conditions. So I have a polynomial that's degree 4, so I need a total of 4 factors. The leading coefficient is -5, and I have a 0 at 3, so how would I write that factor when I have a 0 at 3? If my 0 is at 3, what would this factor be? X minus 3. I have a 0 at -5, so that would be x plus 5, and I have a zeros at -2i and +2i. Remember, your complex zeros come in conjugate pairs. So this would be x plus 2i and x minus 2i. So this would be the completely factored form for a fourth degree because I have 4 zeros or 4 factors with a leading coefficient of -5. On 34, we're asked to find the zeros given that 1 0 is already given. This is a fourth degree polynomial. It has a total of 4 zeros. I've already got one of them. Can you tell me what another one would be? Complex zeros come in conjugate pairs. What that means is I have x plus 2i times x minus 2i as factors. And if I were to FOIL this out, that would give me x squared plus 4 is a factor of this fourth degree polynomial. I can then divide that fourth degree by this quadratic to work this down to a quadratic that I can factor further to get the other 2 zeros. And that's exactly what I'm going to do. When you do FOIL here, you get x squared minus 2i plus 2i, so those are going to cancel out, and then minus 4i squared. Well, the minus 4i squared, I squared is -1, so that's -4 times -1 is +4. So to get this fourth degree worked down, I'm going to divide it by a quadratic factor to get it worked down to a quadratic. So I'm going to take x to the fourth minus 45x squared minus 196, and I'm going to divide it by x squared plus 4. And when I do that, I get x squared and then plus 4x squared, and then I need to subtract this. -45x squared minus 4x squared is -49x squared. -49x squared, and then bring down the -196. Now when I divide, I get -49, and then -49x squared, and -49 times 4 is -196. Change my signs and add, and I get a remainder of 0. So that means that x squared minus 49 is the other quadratic factor of this polynomial. So now I need to factor x squared minus 49. And x squared minus 49 is x plus 7 times x minus 7. It's the difference of 2 squares. So my 4 zeros for this problem are going to be at plus or minus 7 and plus or minus 2i. Those are the 2 i's were from my complex roots that I was given, and then my real roots I found. On number 35, we're asked to express this in completely factored form. Do I have a common factor I can pull out? Sure, I can factor an x squared out of this, and that's going to leave me x squared plus 9. Can I factor x squared plus 9? Sure I can. What's it going to be? Not x plus 3. I tell you what, let's solve this and find our zeros, and that'll help me write my factors. So we're going to solve x squared plus 9 equals 0. So if I subtract 9 from both sides, that gives me x squared equals -9. Now, to get the x by itself, I take the square root of both sides, but I've got to remember the plus or minus. So that means that x is equal to plus or minus the square root of -9. Well, the square root of a negative gives me an I, and the square root of 9 is 3, so this would be 3i. So the completely factored form of this is going to be x squared times x plus 3i times x minus 3i. These are my two complex factors that I got from factoring this quadratic. Actually, I didn't factor it so much as I solved it, found the zeros, and then used those zeros to write the factors. 36, we're asked to solve the polynomial equation. Now I'm not given any hint about how to solve this. I could use the rational root theorem to find possible roots. Do you remember the rational root theorem? It says the roots will be of the form p over q, if I have any real roots, where p is going to be factors of 27. That's going to be plus or minus 1, plus or minus 3, plus or minus 9, and plus or minus 27, over factors of q, and the only factors of 1 are plus or minus 1. So if I have a real root, it's either going to be at plus or minus 1, 3, 9, or 27. The easiest way to do this, since you have a graphing calculator, is to go ahead and graph the function and see what one of those real roots it looks like your answer will be, or one of the roots will be. So we begin by graphing the function x cubed plus 3x squared plus 9x plus 27. And I'm going to go ahead and graph this by hitting zoom 6 to look at it on a standard window. And if I don't see an x-intercept, I may have to go out to the 27s. I'm not seeing all of my roots. It's still working. So let me expand the domain. Let's let our window go from negative 30 to 30. And I know I'm going to have a y-intercept at 27, so let's do the same for our y's. We'll go from negative 30 to 30. I've just done a zoom fit on this, so it's looking like I just want to see my x-intercepts where the graph crosses the x-axis. And there it is at negative 3, and that's the only place it's going to cross the x-axis on that domain. So that means that negative 3 will be one of our roots. So we have a root, or a real zero, at negative 3. So what's one of my factors? So I can take this factor of x plus 3, and that'll give me a 0 at negative 3, and I can use synthetic division to work this cubic function down to a quadratic function. So my constants, or my coefficients here, are going to be 1, 3, 9, and 27. Bring down the 1, that gives me a negative 3. 3 minus 3 is 0, so negative 3 times 0 is 0. 0 plus 9 is 9. Negative 3 times 9 is negative 27. My remainder is 0, and that means that I get x squared plus 9 is my other factor. So if I set this equal to 0 and then solve for x, I end up with x squared equals negative 9. I take the square root of both sides, remembering the plus or minus, and I end up with x equals plus or minus 3i as factors. So my solutions here are going to be x equals negative 3 and x equals plus or minus 3i. Remember, I was trying to solve this. Solving means you set each factor equal to 0 and solve for x. The q will always be the leading factors of the leading coefficient. P will always be the factors of the constant. So these were my possible rational roots. So when I looked at the graph of the function, I saw, well, negative 3 was my rational root, and then figured out I had two complex roots that I found when I did the synthetic division to work this down to a quadratic that I could then solve using the square root property. Number 37, we're asked to determine whether the given equation is a rational function. Remember, a rational function just means you have a polynomial over a polynomial. Negative 3 is a polynomial, x is a polynomial, and this is a polynomial over 1, and 1 is a polynomial, so this one is, yes, this is a rational function. Is 38 a rational function? The numerator is a polynomial. Is the denominator a polynomial? No, it's not, because that exponent is 1/2, and as we just learned, that's a square root. On 39 and 40, we're asked to find the vertical asymptotes. How do we know where to find vertical asymptotes? We find them by doing what? Your vertical asymptotes occur where the denominator is equal to 0, but you can't make that call until after you factor this completely. So I have h of x is equal to x minus 3 times x plus 6 over x plus 3 times x minus 3. Now this x minus 3 factor will cancel out, and that means that I have a vertical asymptote at x equals negative 3 because that's where the denominator is equal to 0 after I simplify this fraction or this rational expression. What happens at x equals 3? You have a hole in your graph anywhere you have a common factor that will cancel out. A hole is not a vertical asymptote. On 40, to find the vertical asymptotes, the first thing I need to do is factor this denominator. So that means that this function f of x will be equal to x minus 8 over, do I have a common factor here? I have a common factor of x, so where am I going to have vertical asymptotes? At x equals what? 0 and negative 7. And I get those by setting each one of these factors equal to 0 and solving for x. On 41 through 43, we're asked to find the horizontal asymptote of the given function. If you don't remember how to do this, you may need to go watch the 4.6 video again. How we find horizontal asymptotes is we compare the degree of the numerator to the degree of the denominator. If the degree of the numerator is equal to the degree of the denominator, we have a horizontal asymptote at y equals leading coefficient over leading coefficient. So the horizontal line at 9/4, at y equals 9/4 would be our horizontal asymptote here. On 42, if the degree of the numerator is greater than the degree of the denominator, we have no horizontal asymptotes. In this case, we would have an oblique asymptote because the degree of the numerator is 1 more than the degree of the denominator. On 43, if the degree of the numerator is less than the degree of the denominator, we have a horizontal asymptote at the line y equals 0, which is our x-axis. If the degree of the numerator is less than the degree of the denominator, the x-axis is our horizontal asymptote. On 44, we're asked to find the slant asymptote. Do you remember how we find the slant asymptote? We divide this to simplify, and y equals the quotient without the remainder is going to be the equation of the slant asymptote. Let's use synthetic division to divide this. What would I put here for synthetic division? 4. And then my coefficients going across here would be 1, 3, and negative 6. So I get 4 times 1 is 4, 3 plus 4 is 7, 4 times 7 is 28. And 28 minus 6 is 22. So this is the remainder, and my slant asymptote is going to be the equation y equals x plus 7. It's what you get without the remainder. When you divide a quadratic by a linear, you end up with a linear function. It's 1x plus 7 because we took an x squared and divided it by an x, and that left us with an x. So the coefficient in front of the x is 1. On the next 3 problems, we're asked to evaluate the expression by hand. On the rational exponent, I could rewrite this as the cube root of 8. And what is the cube root of 8? It's 2. How do I get rid of this negative exponent? So to make the negative exponent positive, I would rewrite this as 1 over 16 raised to the positive 3/2 power. The numerator is the power, the denominator is the root, so this is 1 over the square root of 16 cubed, and the square root of 16 is 4, and 4 to the third is 64. On 47, we have 64 raised to the 4/3 power. I could rewrite that rational exponent as a radical, where this would be the cube root of 64 raised to the 4th. What is the cube root of 64? It's 4, and 4 to the 4th is 256. And if you need your calculator to figure out that's what that is, there's no shame in that. On number 48, we're asked to use positive rational exponents to rewrite the expression. Let's work inside the parentheses first. So this is the 7th root of z squared. I would rewrite that as z raised to what power? 2/7. Remember, the numerator is the power, the denominator is the index on the root. Now, when I raise a power to a power, what do I do to my exponents? I multiply 2/7 times negative 3, and that's going to give me z raised to the negative 6/7. I have to use positive rational exponents, so this would be 1 over z raised to the 6/7. And that would be my final answer. On the last 2 problems, we're solving equations involving radicals. Whenever we're solving equations involving radicals, remember to check your answers. It's possible you could pick up extraneous roots. So for 49, what am I going to do first? So I want to square both sides of the equation. That means I've got to FOIL this out, and that's going to give me 4x minus 3 equals, I'm going to just FOIL it in my head, that's 4x squared minus 12x plus 9. Now what type of equation is this? And how do I solve a quadratic equation? Set it equal to 0, so I'm going to subtract 4x and add 3 to both sides. And when I do that, that gives me 4x squared minus 16x plus 12 equals 0. Do I have a common factor I can pull out here? 4 is a common factor. I'm going to go ahead and pull that out, and that gives me x squared minus 4x plus 3 equals 0. That just makes this easier to factor. So that gives me x minus 1 and x minus 3. So what are my possible solutions here? I get x equals 1 and x equals 3. I'm not going to say they're solutions until I check these. When I check x equals 1, that gives us the square root of 4 times 1 minus 3, and I want to know, is that equal to 2 times 1 minus 3? Well, 4 minus 3 is 1, the square root of 1 is 1, and 2 times 1 is 2, 2 minus 3 is negative 1, and 1 is not equal to negative 1, so this is not a solution. Does that mean that I don't have to check the 3? No, because it's possible they could both be extraneous roots and I would have no solution. So now I've got to check x equals 3. So that's going to give me the square root of 4 times 3 minus 3. And I want to know, is that equal to 2 times 3 minus 3? So 4 times 3 is 12. 12 minus 3 is 9. Square root of 9 is 3. And 2 times 3 is 6, and 6 minus 3 is 3. That is a solution. My one answer here is x equals 3. Alright, let's look at the last problem. I have two radicals here. What do I need to do? I need to isolate one of these radicals, don't I? So, which one do you want to keep by itself? This one or this one? I gotta move one of them over. You guys get to pick which one I move. The first one or the second one? The second one. Okay, so we're going to subtract the square root of 11 plus x from both sides. And that's going to give me the square root of 3x minus 2 equals negative 1 minus the square root of 11 plus x. Right here, if you notice, we have a square root equals a negative because I could factor a negative 1 out of this and make this 1 plus the square root of 11 plus x. And there is no way for a square root to be equal to a negative, so you can stop here and say that there's no solution. And this wraps up the review for exam 3.